So welcome everyone. We'll go ahead and get started. This is our final Zoom Water Scientist session. We are the Vermont Rural Water Association. My name is Liz Royer. I am the Executive Director. We are a nonprofit association that works with public drinking water and wastewater systems all around Vermont. So just a couple of quick etiquette things for today. Using Zoom, you can ask questions in the chat box. I'm not sure, I don't think we have any polling today, so you don't have to worry about the pop-up blockers. If you are watching on YouTube Live, you can ask questions through the comment feature, and we will, we have somebody monitoring our YouTube Live feed, so we can share that with Megan directly. Like I mentioned, this is our last session for the month of May, but Lake Champlain Sea Grant, one of our partner organizations, they have Zoom Scientist sessions through the month of June. Their sessions are held Tuesdays and Fridays at noon. So if you can, go ahead and type in the number of people watching on your screen and what town you're located in. You can do that either, again, in the chat box on Zoom or in the comments on YouTube. So today's scientist is Megan Moir from the City of Burlington Public Works Department. She is the Water Resources Division Director, and she's going to be talking about the history, careers, current opportunities, a little bit of everything today. So thank you for joining us, Megan. And again, this will be recorded and available on our YouTube channel, so please share with family and friends.
Hi, folks. Thanks for that introduction, Liz. Let me just go ahead and work on sharing my screen here. Let's see if I do that, and then okay. Liz, can you confirm that you can see my slides and not my note situation?
I can't see anything yet.
You cannot. Okay. Trying again. Let's move this out of the way. What are you seeing now?
Now I see the slides.
Nice. Okay, now I just need to get my other slide. There we go. Okay, everybody's all set. So thanks again. Yeah, so we're going to be touching on a number of different subjects. As anybody who knows me, I can talk about water, wastewater, and stormwater until the cows come home. And we're not going to torture you for quite that long, but we are going to go through a whole bunch of topics that I think are really interesting. First of all, I wanted to say that today's pandemic presentation is brought to you by the tardigrade or water bear. So one of my favorite little creatures. It doesn't matter what you do to them, boil them, deep freeze them, crush them, dry them out. Apparently they have been blasted into space on the outside of a satellite and survived and even laid eggs. They've been blasted with radiation, survived. As wastewater operators know, they are found in old or mature wastewater sludge. I've seen them in pond water, and then apparently also people have reinvigorated them from sediments that comes from gutters. One of the things that enables them to do this is that they go into this state called a ton state, and that's really where they're most indestructible. And I thought they were an appropriate creature for all of us who are experiencing COVID-19, because we are going through a lot. We're going through a lot of things that we've never gone through, and I sort of think of myself and others as being in this ton state where a little bit in my shell, trying to figure out how to get to the next day, and just taking it day by day. So a little background on me, how I got into water. For me, it really all started with Buffalo Bayou, which is a bayou that goes through Houston, Texas, where I grew up. Houston is known for lots and lots and lots of rain. I now know also for lots and lots of combined sewer overflows. I spent a lot of time playing in puddles, sometimes getting attacked by fire ants. And I ended up going to Rice University. And while my original career plan had been to go to medical school, after I took a couple of what I called mud biology courses while I was there, I really realized that I would rather spend the rest of my life and my career with folks who spend a lot of time outside, get dirty, get muddy, and really figure out how this world works. As part of my undergraduate degree, I ended up doing an honors thesis project on Buffalo Bayou, looking at it as an urban stream. And in particular, there's a section of Buffalo Bayou that goes through a little bit of a naturalized area, at least for Houston, and then turns into a concretized channel. And I did some field work and also some other research on different fish populations that have been studied and other water quality characteristics, and kind of just learned about how important the adjacent banks and landscape around a stream was for the water quality in the stream itself. Eventually making my way to Vermont, which is a whole other story. I did do a master's in water resources at UVM. I then landed in private consulting, where I was focusing mostly on sort of sites management, hazardous waste sites, but had the fortune of the person who was doing stormwater management at that consulting firm left. And as consultants often do, I ended up teaching myself a lot about stormwater management, and developing stormwater management plans for different sites. When a job came up at the Vermont DEC stormwater section in 2005, I did leave the private consulting world and join the regulator world. And I was there for a number of years, as well as at the Center for Clean and Clear, which was focusing on Lake Champlain's cleanup process at the time. In 2009, Steve Roy, one of my mentors and one of our senior water resources engineer at the city, called me because the city was starting its stormwater management program, and they needed a stormwater program manager. And so I jumped at that chance to have my own budget and my own little laboratory where we could really try out some of the newer science that was coming out around stormwater management. And then more recently, in 2016, our Water Resources Division head, Lori Adams, who had been there for almost 30 years, left for, I guess, somewhat better waters, I suppose. She is now managing a drinking water facility at Pine Island down in Florida. So she's sort of a good transition for her towards her retirement. And so again, in 2016, I became, and I learned this after the fact, that I am the 25th superintendent of water. So since 1867, there have been a whole long slew of superintendents of water, and I have the fortune of being the 25th. One of the things I really like about water is, it's all the same water. People have heard that the water you're drinking now was peed out by the dinosaurs, and that's true. It's constantly recycled. So we always have to keep that in mind whenever we're doing anything with water, that there are downstream consequences. And at some point, what we do to the water now and how well we clean it is going to come back around at some point into our lives. And one of the things that we're really, I think, what's really beneficial about how our organization is set up at the city is it is a one water organization. The drinking water facility and system, the wastewater system, and the stormwater systems are all under one division head, which is me. And there's a lot of good reasons for that. As I said in that previous slide, anything we do, if we are not doing appropriate wastewater treatment or stormwater treatment, that can have an impact on our drinking water. We have a really good drinking water treatment system, but if you look long down the road of where humanity may go, and not so much for Vermont, but certainly other more urbanized areas, we really have to be careful making sure we're completing the loop in all these different places. So in Burlington, I'm just going to give you a little overview of just our systems before we get into the history. We have over 110 miles of water mains and about 900 fire hydrants. We use GIS, Geographic Information Systems, a great deal in managing all of these assets. The photo that I have here depicts the water main systems that are in Burlington, and also depicts, if you've ever heard anybody talk about the high service and the low service. So all of the areas in blue are actually pumped. The water is pumped from our drinking water treatment plant down here on the lakefront, in between the Moran plant and the Coast Guard station, and it is pumped up into this low service system and also into the reservoir, which is on Main Street. So between the Main Street reservoir and the pressure coming from our pumps at the Lakeside pump station, we're able to maintain sufficient pressures throughout the city. For the folks who are on the tippy top of the hill, in order for them to have sufficient pressure, especially at places like the hospital where they are a multi-story building, we actually need to pump the water from the reservoir, from the 7 million gallon reservoir, up into the water tanks. One which everybody can see from the highway is the 500,000 gallon UVM storage tank, which is sort of a traditionally looking storage tank. And then there is also a small one, I believe 150,000 gallons, that is on the Redstone campus. And that one's been in service for quite some time. On the stormwater, combined sewer and sanitary collection system, similarly, we do use a lot of GIS so that we can know where things are and keep track of the condition of these pipes. We have over, I think, 130 miles of pipe when you look at all the pipes together. And I believe at our last count, although we're always finding ones that we didn't know about, we have on the order of about 170 stormwater outfalls, which were all these little points here on the map. Liz, I don't know if you can hear. Can you see my, I can't remember if there's a way to get a pointer.
I do not see your pointer.
Let me see if I can get a pointer.
You should just be able to use your mouse cursor.
Yep, are you seeing it now? No.
No.
Maybe now?
Oh, yep, there it is.
Yeah.
Okay, well, I'll have to turn my head to do it because of the situation of my multi-screenage. Let's see. So I was just talking about what we call our horizontal assets. We also have a number of what we call vertical assets, which are our wastewater treatment, our water treatment facility, our pump stations, and our wastewater treatment plants. So in Burlington, and it's interesting, we actually have been doing a study to look at whether or not it would ever make financial sense to consolidate these wastewater treatment plants. And the short answer is probably not because of the geography. But we do have 3 wastewater treatment plants. Our largest facility, which is on the waterfront, is Main Plant, which has about 5.3 million gallons a day capacity. We also have East Plant, which is over on Riverside. And if you don't know where it is, because it's a little bit down the hill, if you're driving on Riverside towards Winooski and you smell donuts from Coffee Cup, and then you smell barbecue from Bluebird Barbecue, and then you smell something else, that's the Riverside plant. And then down here at the most northern reach of North Ave is North Plant. We do still have, and we'll talk a little bit more about these, 5 untreated combined sewer overflow outfalls, which are shown in the with the red hash marks. We've gotten most of those under control in the recent years, with the one exception being the Pine Street barge canal, which does still go off with some regularity and is sort of our major area of focus right now. Liz mentioned, careers. I don't have a lot to say other than if you have any inkling or interest in water, wastewater, or stormwater, we need you, we want you. Get in touch. We don't have any internships this year because of COVID, but we do generally have those. We are getting to a point where we really, really, really need people to be going into particularly water and wastewater operator positions. We have a lot of folks who are getting close to retirement, and in particular, folks who have any sort of mechanical or electrical inclination or have experience with programmable logic controllers are really in short supply across the nation, and Burlington is no exception to that. We also are looking for folks who may be more sort of on the labor side in our distribution team, which are the people who fix the water mains and do the water line services, and then our meter shop technicians who go into homes and make sure that our meters, which is how we measure the amount of water that people are using, are in good repair. In a sort of more generalized capacity, we also have a need for field technicians. These are folks who have strong science and engineer skills, don't necessarily have to be an engineer, and also have a strong foundation in GIS. Certainly planners and engineers, particularly engineers who have a specific water resources focus. And then we're also looking for really great customer care and billing team members. We actually have a position open right now for senior customer care. And, we're looking for somebody potentially with a bank background or maybe medical billing, somebody who has been able to deal with the level of research and some degree of being able to learn about technical things, who can then really help explain the numerous complexities of our system to our customers as they're trying to navigate their bills. So with that, I was just going to dive a little bit into our water resources history, which I find super, super interesting. In the 1800s, Burlington started to see, a huge uptick in growth. And there were some rudimentary water systems and springs throughout Burlington. But the health officer at the time noted that they were still having a lot of trouble with waterborne illnesses, cholera in particular, and sort of stated the need for the city to really be a leader, even back then, in making sure that there was an abundant supply of fresh running water as well as good sewerage. Basically, the city can't exist without a good water resources foundation. And so very quickly after that, the city determined that they were going to purchase the Burlington Aqueduct System, which is the company that was sort of dealing with water at the time. And these photos here are just showing the location of one of the older aqueducts that I believe was fed by a spring, and or water was hauled up by horses from the lake and deposited in the cistern. So this is on the corner of Pearl Street and I think South Williams. And interestingly, this last year, we actually had a sinkhole that started to form, and it was directly on top of one of these cisterns. And so we actually were able to get a look into these. It was one of the harder days of my life because for whatever reason, I had a strong attachment to the cistern, and we did have to fill it with flowable fill to make sure that there were not further collapses, but not without first documenting the sort of beauty of this old cistern that, really was one of the initial parts of our water system. So in 1866, the city of Burlington made plans to purchase the Burlington Aqueduct Company, and then right from there went into an improvement plan for constructing a larger waterworks system. They built the pump house, which is on the waterfront in the same location as today. They laid a short intake 50 feet offshore, which you can imagine did cause problems later on. And then they also built the first part of the North Reservoir system, that Main Street drinking water reservoir that I mentioned. I don't know what happened to that slide. It's a animation slide that I forgot about. So in those times, there was one sort of pipe system that was built from the lake and pumped water up to the reservoir. And then from there, they built out the rest of the distribution system. But at that point, it really was what we call lake to tap. So it was raw water, no treatment, sucking it directly from the lake and bringing it directly into the reservoir. At that time, when they built the reservoir, they also built the gatehouse, which you can still see today, built in 1868. And it was this gatehouse was later retrofitted, not that much later, but a couple of decades later, I believe, to the pump house. And this is where the current pumps are that pump the water from the reservoir up into the storage tanks that we mentioned before. This pump house is quite old, and we are pursuing design options right now for how to basically mothball this, retire this building, and probably build a new modern pump house behind it, but certainly maintain this as it is a historic landmark. One of the cool things about the drinking water system when this came into being, it wasn't just providing drinking water to folks, it was also providing fire protection. So as all of these houses were built closer and closer to one another, the level of fire risk goes up. And so with the pressurized system that the Burlington water work system was putting in place, the fire department was able to transition from just using portable pumps to hoses, which actually connected to the pressurized system of hydrants. And it's really interesting. You can see how proud the mayor was at that time, because almost every mayoral address in those years mentions the importance of the new waterworks in aiding the fire department in kind of getting to this modern era. So meanwhile, so that was the drinking water side. On the sewer side, not a lot was going on, but they were advancing this sort of concept of sewerage, which at that point was really just about collecting sewage safely from people's homes and getting it as far away as possible, i.e. to Lake Champlain. So they did start constructing some sewers in the vicinity of College and St. Paul. And the sewage outfall, there was a sewage outfall at the bottom of College Street. And then the other place that sewers were draining was into the old ravine, which is now fully covered over, and they eventually did lay a pipe and is referred to as the ravine sewer. And that drained at the bottom of Maple, very close to where our existing wastewater treatment plant is. There's some mention in those times of stormwater and storm drains also being connected to the sewer system, which you can see kind of pointed us in the direction of having a combined sewer system. At the time that they started getting better about getting sewage to the lake, the city health officer started to notice some additional impurities of the lake water on the near shore, and started talking a little bit about the need to extend their intake, the 50-foot intake, out into deeper water. So folks were realizing that as we've got better about concentrating our waste and putting it in one location, that there were going to be these downstream impacts, i.e. on our drinking water, which at that point was not being treated at all. Some other evolutions that happened were more storage was needed. The high service, at the time, Mary Fletcher Hospital, which we now have is the UVM Medical Center, was nearly completed and needed some additional high pressure water there. And so there, in addition to the ground tank that was already in place and built in 1880, we built an elevated tank, which is the Redstone tank. If you drive by it, I call it Sputnik, because we do put a fair number of cell towers on it as a little bit of extra revenue. We also needed more storage on the low service system. And so in addition to revamping the North Reservoir, we constructed a second reservoir, about 4 million gallons to the south of that, bringing our total reservoir capacity to about 7 million gallons. But we still were having water quality problems. If you look at the data from 1883, 1894, people were still dying from a lot of different waterborne diseases. And so in 1894, the city endeavored to install a new raw water intake as far offshore as possible, and extended a pipe about 2 miles offshore. And we do engineering projects, and even an intake project at this point would be challenging, but when you look at some of the pictures of these guys installing these large diameter pipes offshore in these really heavy diving suits, I feel really lucky that we live in the day that we live, because who knows how many folks probably died laying this pipe. The problem is that the deep intake didn't work. They continued to see waterborne illnesses. And basically what we think happened is that the designers hadn't taken into account that there were flows coming from the Winooski River. So they extended that pipe very far out towards Apple Tree Shoal, which actually put the water intake closer to the effluent, if you will, coming from Winooski River, particularly when the winds were such that there was southerly flow in that Winooski River, which drains a very, very large area and also is probably draining sewage. So they realized that that wasn't going to quite work. And so they kind of went back to the table and realized that they were going to have to either purify sewage and get everybody else to purify it, or they were going to need to filter the drinking water. And at that point in 1904, there wasn't really a practical option for purification of sewage. And so they decided to go with water filtration, constructing a filter using sand filtration with a little bit of alum as a coagulant before. There still wasn't any disinfection at that time. More years passed by, people still got sick, still got typhoid, and we followed a lot of other US cities and did begin to do some amount of disinfection by adding hypochlorite of lime or bleach to the coagulation basin. Extending into the 1920s, still had typhoid, and so eventually we replaced the hypochlorite system with a more efficient gas chlorination system. One of the things when I looked at the history I found really interesting was the early wastewater treatment conversations. As early as 1911, the city engineer were talking about the need for a sewage sterilization plant. They realized that there was a connection. They did construct a very small one right off of Fletcher Place, off of Colchester Ave, which I believe was primarily for the hospital. And they were working on doing this construction of additional sewers. But it actually took, this baffles my mind, it actually took until the 1950s to even really get it on the ballot. And then 1953 was when we finally got wastewater treatment, which is just baffling to me, that we were just dumping raw sewage all that time up until 1953. But yay, 1953, we did have a rudimentary wastewater treatment plant that was constructed, which involved clarification, so settling out of solids, and then probably hitting it with vast amounts of chlorine to kill the bacteria. The North Avenue wastewater treatment plant was constructed a little bit later on in 1959. This also involved the construction of a sewer river crossing. So in order to get the water from portions of the New North End in Burlington, the best way was actually to send the flow this way and cross the river once, go over into this area in Colchester, and then cross the river again. Understandably a little risky. I can't remember when, it was prior to my time, there was an incident in which one of these pipes did break and did spill a large amount of sewage into the river until such time that it could be fixed. We do have much better processes in place as far as dye testing and river inspection by divers to make sure that that does not happen in the future. So I'm going to skip through this. This is some sort of earlier iterations of wastewater treatment upgrades. There certainly Burlington saw at that time in the 1950s, large increase in users. In the 1960s and 70s, Burlington Water actually fed water not only to Burlington, but also to South Burlington, part of Williston, Winooski, and the Colchester Fire District. In 1972, those of you who are in Chittenden County probably get your water from Champlain Water District, and they started their own treatment and supply facilities, and we did certainly lose some customers at that point. In the 1970s, there was a lot of scrutiny on our water treatment system and the need to comply with the Safe Drinking Water Act. At that time, we thought, and we were on a trajectory where we also thought we were going to need additional capacity at our plants. And so a $12 million complete treatment plant upgrade, including lining and covering of the reservoir. So that reservoir that's on Main Street that now has a roof on it was actually uncovered until the 1980s. And we also put in a new 30-inch intake. So with that, we did a number of projects in the 80s. We overhauled the treatment plant and got our treatment plant to where it is today, a modernized sort of water treatment plant. One of the cool parts, I guess, although I would love that revenue right now, is recall that I had said that the original predictions of how much water we may need to produce were in the 10 million gallon a day region when this plant was designed. On average, our plant uses about 3.5 to 4.5 million gallons a day. So we really are quite overbuilt. And early on, the water operators realized, well, if we don't need all of that capacity, maybe we should optimize the plant to provide even better treatment. And so in fact, Burlington water is treated through a filter twice. It goes through, originally it was supposed to split and go through 2 separate filters and then come back together. But now we're able to use those filters in series. This is a little bit of a funny slide for me. Spent a lot of time in this conference room. A lot of things change around us as a municipal facility that doesn't necessarily have a lot of money. The same conference room that was built in 1984 in the admin building is exactly the same conference room as we have in the 2020s. We do have some screens and some other technology, but most everything has not changed. We're going to spend a little bit more time on this when we get into the challenges section. 1980s were the major area of focus at that point was starting to deal with our wastewater and our combined sewer improvements. We had a large number of combined sewer overflow locations at that time, and actually discharged on the order of about 170 million gallons or more of combined sewer overflow into Lake Champlain every year. We still have a combined sewer overflow problem, but I can tell you that it is much less than that time. The youngster to the sibling trio of water wastewater is, of course, stormwater. I always say that it's not really a stormwater problem, it's an impervious problem. But as Burlington started to build out, and particularly into the 1980s, water resources professionals began to realize that while wastewater often presented, particularly combined sewer overflows, presented an acute impact of discharging bacteria-laden water into places where people might want to recreate or swim, stormwater runoff really represents a chronic impact. The vast amount of stormwater runoff and the pollutants that it generates, you can't necessarily see it in the moment, but if you look at trends over time, it really can do a lot of harm. And a slide that we have later on, talks about specifically from a phosphorus perspective, acre for acre, urban runoff is one of the bigger fish that we need to catch in our fight against phosphorus runoff. So the folks I think in the early 2000s were realizing that Burlington really needed to do more for its stormwater runoff and even its separate storm sewer system, and formed the Burlington Stormwater Program in 2009, which has dedicated funding. So we actually charge people for water usage, for wastewater, and then separately, based on their impervious surface, charge them for dedicated funding that goes into our stormwater program. So with that, before I get into our challenges or opportunities, I don't know if anybody has any particular questions about Burlington history. We will talk at length about the combined sewer overflow, because I know people often have questions about that, but any questions out there?
Those watching, feel free to type your questions into chat. I'm wondering, Megan, I'm having a hard time picturing where the Main Street reservoir is. What does it look like?
It's if you're driving into town, you get off exit 14 and you're driving and UVM is all on your right. Just before you pass the UVM green, there's fences and frankly some kind of ugly terracing to your left. And next time you're in town, when you see the gatehouse, let's see if I can get back here. So it's on your left, so to the south of Main Street as you come in, right before you get to South Prospect. So there's this berm area and this terracing, and then there's a roof. So you can't really see the reservoir so much as you can see the gatehouse.
Okay, interesting. I've never paid attention to that before.
Yeah, so I mean, if you look on Google Earth or whatever, you'll see a massive roof area, which we every year try to figure out how we can do something cool, like put solar panels on, and I haven't given up on that dream. Well, originally we were going to do a green roof, but we're not sure structurally that the roof can handle it. But we do think that potentially we could move forward with a solar plan, which would be really cool, just because it's a roof structure doing nothing.
Megan, I had a question about the 10 MGD that was predicted. Was that, did they think there was going to be that much development, or was that more of, now that we're conserving water and have, special fixtures that we're actually not using as much?
I think it was a little bit of a whole bunch of things happening at the time. I haven't parsed it out exactly, but like CWD came into being in the 1970s, which I think is when they were starting the design. So there was that piece. And then also Burlington, from what I've heard, used to have a lot more water heavy industries, such as I think there was a bottling plant. So the soda plant that's on Pine Street, I think was an actual, I don't know if it was Coca-Cola or some other type of bottling, but there was just a lot more water usage. And between when the designs happened and when the plant was actually built, something changed. So I think it was a combination likely of the CWD plus industries changing. Certainly over time, when I do my rate models, it's interesting because even though we do anticipate some amount of growth in the city, and we've seen growth because of what you said about conservation, our growth, it doesn't necessarily, just because we're building more units of housing, we don't necessarily see vast increases in the amount of revenue we get, which is a big challenge when we're trying to figure out how to pay for all of this stuff. That, and we don't have a lot of dense development. I would love to be in a place like New York sometimes, where you have a whole bunch of people in a really tight space who are using a whole bunch of water. I could do so much with that money, whereas we're still kind of spread out. But I think we'll have a little bit increase in growth over time. But that hurts you on the wastewater side. It gobbles up your capacity on the wastewater side. So we don't want to see too much growth.
Thank you.
No problem. So I was going to spend a little bit of time talking about our challenges or opportunities. One of our big challenges has been the age of our water distribution system. So the series of pipes that are in our roadways that carry the water both to the reservoir as well as to people's homes. And the useful life of a typical metal water pipe is about 75 to 100 years, depending on installation as well as soil conditions. So a younger pipe in, say, the south end of Burlington, where we know there to be corrosive soils, may not last as long as some of the really, really, really old pipes that we have in the old North End, where they are in happy sandy soils and don't have as much much to fight with. But just looking at pure age, when we did this analysis in 2016 before our water bond, we unfortunately found that there were about 42% of our water pipes were already older than 75 years old. And almost 25% of them were older than 100 years. So you can imagine that is concerning because in order to get back on an average 75 to 100 year replacement schedules using 88 years as a target, we would basically need to spend $2.3 million annually over the next 25 years. We kind of dipped our toe in the water in 2016. We were very thankful to receive 88% voter approval on an $8.34 million water bond. And with that money, we have been able to reline, I believe it's just over 8 miles, reline or replace over 8 miles of our system in the last 3 years. We have a little bit left to do, but we are about to run out of that original bond authorization. And so, one of the things I have brought up with the mayor is that if we want to continue on some sort of trajectory, maybe it's not $2.3 million a year, maybe it's $1 million a year just to keep us pointed in the right direction. We are going to have to start thinking about another water bond. And it's not just the pain of us having to deal with water main breaks. It is also dealing with, the reduction in pipe capacity that happens. All of our metal pipes do have naturally forming tuberculation. So that's internal corrosion or rust. It forms in all metal pipes everywhere. It's not lead. It is just a naturally forming product. And over time, that can cause a reduction in the amount of water that pipe can carry. It also, unfortunately, causes, water quality more from the discoloration or aesthetic standpoint than a danger. When there's any major pressure changes in the system, people will often get cloudy water in their homes and they have to run their water until clear. And we do believe that Burlington citizens expect, certainly, but also deserve clear water at their taps. So that was also a major driver for getting this project going. The other thing was from a pure sustainability standpoint, we were noticing that oftentimes we were seeing a lot of water main breaks, potentially because of additional vibrations that would happen after paving. So the city and the general fund, which is funded by taxpayer, would go through and pave a street. And then unfortunately, Megan's water pipes would break and we'd have to rip up the street right afterwards. So not super smart. Anytime you cut into a newly paved street, you've basically, you've undermined all of the effort and all of the money because any of those little seams are likely to become potholes very quickly. The good news is that we're seeing some decline in the number of water main breaks. So the numbers I can really only super trust because this is when our GIS came into play after 2015. But we started doing our relining project in 2017. We have had 1 or 2 bad years, but overall, the number of breaks that we're seeing, while it's not quite meeting the AWWA standard of 15 breaks per 100 miles of distribution system, we are at least managing to stay below the national average. So that's on the water side. Certainly on what we call the clean water, which is both wastewater and stormwater, we've got a ton of challenges. We have just pure infrastructure challenges. So even before we get into talking about, reducing phosphorus to Lake Champlain, we have pipes that are breaking. We have outfalls, stormwater outfalls that when we started doing inspections looked like this. This one, which is at Gazo outfall, has recently been repaired, but these projects are expensive. I think we spent $350,000 or $400,000 repairing this particular outfall, and we're on target to have to spend millions of dollars more to tackle some of our worst outfalls. The pipes themselves, both on the sanitary side, so our sanitary pipes are quite old and often have large breaks in them. Interestingly, our younger stormwater pipes, a lot of this stormwater system was laid in the 80s and they were using corrugated metal pipe. Probably cheap, pretty light, great. The problem is that corrugated metal pipe doesn't do well with all the salt that we have to put on our roads. And so when we've done an inspection of our corrugated metal pipe, almost 50% have some sort of structural deficiency, and about 10 to 20% of those pipes need near-term repair. Fortunately, our Clean Water Resiliency Plan, in addition to providing funding for some wastewater treatment plant upgrades, is also providing some funding for us to tackle a relining program on our sanitary and storm sewer side. And I think over the next 2 years, we're going to be trying to line about 8 miles of these sewer systems. As we head into summer, and particularly this really, really warm day, certainly on my mind are the algae blooms, which we have been seeing in greater frequency. This is certainly due in part to the constant onslaught of the excessive nutrients, primarily coming from developed lands, but wastewater treatment plants do play a role. But also some of the other issues, I think, of climate change with seeing the warmer water, the water in the lake heating up more quickly. I mean, if we're getting a 80 or 90 degree day at the end of May, it's actually a little concerning for what the summer may look like with regard to algae blooms. But that combination of the excess nutrients, warm water, as well as calm water, so these days when there's no wind, can cause these cyanobacteria blooms to form. As I've already said, and there's a typo there, Stormwater. We get really focused on farms and we get really focused on wastewater treatment plants. But when you break it down to the load, so if we look at, let's see, the orange here is the developed land. So overall, wastewater treatment plants are still quite a small proportion of the load. Sometimes there's a tendency to go for that because it's quote unquote easy to grab because it's an end of pipe solution. But folks do need to know that the costs involved of upgrading to improve phosphorus control are huge and substantial, and they're all being focused in this sort of end of pipe solution where they don't have any other co-benefits. So that's something that we're kind of weighing carefully. But the developed lands here, while it's 16% of the overall load, when you break it down into the 16% of the load, but only 4% of the land area, you end up with a huge amount of loading per square mile. And so that's why we really do need to make sure that our cities are focusing as much as they can on both non-structural ways of managing stormwater runoff, so street sweeping and catch basin cleaning, as well as looking at how we can retrofit our landscapes to put in stormwater treatment. On the sort of other side of the stormwater runoff coin is our issue with combined sewer overflows. So for those folks who aren't familiar with what a combined sewer is, in a lot of the older cities, particularly across the eastern seaboard, the wastewater and the stormwater go into the same pipe. So the street storm drains are draining to the sewer, as well as the poop and the pee that comes from anybody's home or business into the same pipe. Now, generally, this is a good thing because it means that the stormwater, which otherwise would get zero treatment, and we talked about how stormwater has a chronic pollution issue, it, under a lot of situations, does actually get treated by the full treatment train of the wastewater treatment facility. However, the flip side is that when this pipe becomes overwhelmed with stormwater and cannot fit all of the stormwater and wastewater to the wastewater treatment plant, and also to protect the wastewater treatment plant itself from being overwhelmed by the flows, there are these relief valves out in the system which allow some amount of combined sewer, so a very small percentage of sanitary waste with a larger volume of stormwater to spill out into a receiving water. The other benefit of these relief valves is that it prevents combined sewer from backing up into people's basements. So people who are on the combined sewer should have what's called a backwater prevention valve, which prevents water from the sewer main from going up their sewer lateral and getting into their basement. But a lot of older homes do not have that. And if we started blocking off all of these combined sewer overflows, we would in fact see more and more people with the rest of the world's sewage in their own basement. So it's a terrible choice, but it is better generally to get it to a place where it can kind of spread out than to be putting it into people's homes. As I alluded to before 1994, we were discharging massive volumes, like huge volumes, 170 million gallons, likely more, going into Lake Champlain, Inglesby Brook, Winooski River. We had 11 different CSO locations. And then so I think in the late 1980s, a plan was put into place to figure out how to tackle this. So in many places, we did pursue at that time the low-hanging fruit of sewer separation. So in a couple places in the Old North End, and to a large extent in the New North End of Burlington, we went through the trouble of laying a separate pipe and then connecting the catch basins to that separate stormwater pipe. Now recall, the water is now going from the roadway, from the oily and greasy, from whatever's deposited, people letting their dogs poop on the ground, going right into a pipe and right into a river with absolutely no treatments. At that point, it was viewed as the best thing to do, but we now know that there are those chronic impacts. So we basically did sewer separation where we could, but in the downtown core, this purple area, sewer separation was not really feasible. And also because even at that time, some of our engineers realized that there could be this trade-off and that maybe we needed to figure out a way to provide better treatment to this combined sewer overflow. And so the major upgrade that was done at the main wastewater treatment plant involved actually, and I can't remember the phosphorus removal that we had at the time, but it improved the overall phosphorus removal of the plant for just regular sewage treatment down to 0.6. We often are seeing numbers much closer to 0.2 and sometimes below 0.2 with all the chemical optimization that we've done. But that is the sort of initial capacity or initial removal benefits that were achieved. We increased the overall sewage treatment capacity from 4 MGD to 5.3. And then most importantly, they improved the ability of the full treatment train to deal with a peak flow rate of up to 13 million gallons. Now, your typical CSO event, when you started consolidating all of those previous CSO outfalls, certainly gets above 13 MGD. And so what they then did is install this thing called the Vortex. So when the treatment capacity and the hydraulic capacity of the full plant is overwhelmed, water starts getting shunted to this Vortex, which acts as uses centrifugal force to get as many of the remaining solids to drop out. And then those solids, the dirtiest part of that water, does pass through the wastewater treatment plant. Most importantly, the water that leaves the Vortex is then hit with bromine, which is a strong disinfectant, and it brings the bacteria level that is in the combined sewer overflow down to a level within Vermont water quality standards. So that's what it has enabled us when we look at what we were doing since 1994, right? The 170, likely more, million gallons of untreated CSO volume. Now these days we are having a CSO, but it is a treated CSO. So and also we're able to fully treat. So I think in 2018, the stormwater portion, so when we look at the increase from our daily flow to a storm event, we were able to treat over 200 million gallons of stormwater through the full treatment train. We were also able to deal with about 100 million gallons of flow that went through the Vortex and was treated, i.e. screened, and then heavily disinfected. In 2018, which was certainly one of the least favorite parts of my career, we did have a number of plant infrastructure issues, which resulted us in discharging about 12 million gallons of treated but not fully disinfected water. And in that year, we also had about 1 million gallons of CSO. And it fluctuates from year to year, but as I said, we do still have CSOs primarily from our Pine Street Barge Canal. But I do take great solace in the fact that compared to this number, this red bar, 170 million gallons, and if we're discharging on order of 1 million gallons a year of untreated CSO, still not desirable, but we are in such a much better place, and we've done so much work since those times when we were just discharging things into the lake. I'm going to skip this for now. So in addition, more recently, separate from the increased capacity at the plant, we've really been focusing on trying to grab stormwater, both separate stormwater as well as combined sewer runoff, or runoff to the combined sewer, to slow the water down. And when and where possible, these are all examples here at the top of infiltration systems. So instead of letting the water that goes from a catch basin or from a roadway get into the pipe to get to the plant or to get to a pipe that then could cause a combined sewer overflow, we're letting that stormwater reconnect with its natural hydrologic cycle by soaking into the ground. If it soaks into the ground, it doesn't cause runoff, it doesn't cause problem, it doesn't get to a pipe. It really is in its happy place, and we like to keep it there. So these are just a couple of examples of those infiltration projects. And the good news is, and this is a little bit of old data, but once we started doing these infiltration projects, we did start to see some of the known CSOs that we had at the time at North Champlain and Park in particular, a little bit to Gazo, but particularly North Champlain and Park. You can see Park had huge numbers of combined sewer overflows. This is just a frequency chart. And after we started implementing some of our infiltration projects, which happened in this area, 2010 to 2012 and 13, we really have seen very few frequency of overflows in those areas. Unfortunately, at the same time that we were saying, yay, we've done it, we've tackled, or we're so close to tackling our combined sewer overflow problem, a stormwater technician was doing some mapping and identified what we now call the Pine Street CSO. It was not identified on our maps. Once we found it, we did report it to the state. And as I've said, that one is now the one that causes the most trouble for us. The challenge is, not that I really want to be in the 1980s challenge taking on these problems, although I think it is sometimes similar, is we're now getting to the tippy top of the tree. In the 1980s, we tackled the low-hanging fruit. We spent a lot of money, but we were able to do a lot with that money. And now the fix is a lot more complicated. What do we fix first? I've expressed a number of challenges that we have, and they're big challenges, and they're going to cost a lot of money that the ratepayers may not be able to afford. We got to remember that the 80-20 rule, I think the Pareto principle, this last 20% is probably going to take 80% of the money that Burlington has spent over its many, many years tackling water quality. When you look at, I call this in the map of my brain, our integrated water quality planning process, there's a lot of connections between what we do at the wastewater treatment plant, what we do for combined sewer impacts, what we do for separate storm. And there's so many different ways that we could tackle that. One of the things that we know we want to do, to the extent that it bears fruit on the water quality side, is that we don't want to just go after the easy thing if we could find something else that would have maximum co-benefits. So when we look at, potentially upgrading the wastewater treatment plant compared to doing green stormwater infrastructure, which could slow down the water in the combined sewer system or filter the water in the separate storm sewer system, we want to be finding the solutions where we're getting the maximum benefit or getting the maximum pounds of phosphorus removed for the money, but also the maximum benefit. So if a project, instead of just doing a tank underground, if a project can be providing aesthetic improvements, shade trees, habitat for bees and other wildlife, we want to be going after those. One particular place we've done a lot of collaboration with our general fund engineers who manage the streetscape is combining traffic calming projects with stormwater projects. So if you're ever driving on North Street, at the very top of North Street, so Colchester Ave, turn right on Mansfield, turn left on North Street. Some of our best examples of stormwater bump outs are right there, and they're providing traffic calming for the neighborhood, which is it's a common cut through street, as well as soaking up all the stormwater that used to just run into a catch basin. A more recent example, and the plants are looking a little sad because I think this picture was just taken after the winter, but more and more stormwater management is becoming an integral component of our urban streetscape. The recent redevelopment of St. Paul. So when anybody's in Burlington, downtown Burlington, and we do hope you come back, please take a tour down the blocks of St. Paul, just to the south of Main Street, where you will see some sort of urban examples of stormwater bump outs, as well as, if you look here, these are stormwater pavers. So the runoff from the sidewalk is going onto these pavers and soaking in. These urban trees are in silvacells, which are providing adequate soil volume, which means that these tree canopies are hopefully going to grow big and lush and also provide a stormwater benefit. One of my favorite things to do in a rainstorm is go stand under a tree, not a lightning storm, but a rainstorm, you know, and just be amazed by how little water actually gets through those trees. They are capturing the water on their leaves and on their branches and evaporating it back in the sky. And it's stormwater that never becomes runoff. And if it's not runoff, it's not a challenge for me. And I'm gonna end.
I just wanted to, yeah, I was just gonna say, I give you a 2-minute warning here.
Oh, well, perfect. I'm right on time, as long as nobody has questions. This is my last plug, which is to consider your choices when paying for drinking water. I know none of us have deep pockets, and when I have to pass a rate increase, I do consider the economic issues of all of the ratepayers. But you know, drinking water right now is still so cheap. When you look at the cost of what people are paying for drinking water in a bottle, and it's often, you know, way more than what you pay for gasoline, and you look at what a Burlington resident pays per gallon to actually be delivered to your home, and we're looking, you know, less than half of a cent. I just think that that's really important, and across the nation, we're, you know, all struggling with making sure that we're taking care of our systems, and in order to take care of our systems, we are going to need more money. So with that, I will take any additional questions now that I've taken up the entire hour with my stuff.
Oh, thank you. It was really interesting. I learned quite a bit, and you know, I've been in the Burlington area for 20 years now. So great
Yay.
job.
Yeah, thank you, Megan. It doesn't look like anyone's typed in any questions, but that was awesome.
Good, I'm glad. Like I said, I can talk about it for a while. As my wife will attest to. Sometimes she's like, shh, no more water.
All right, so I think we'll end it here, but thank you again, and please share our YouTube channel with others, and you can watch this recording there later.
Awesome.
Thank you, everybody.
Thanks very much for the opportunity. Appreciate the work that Vermont Rural Water does for all of us.
Thanks, Megan.
Okay, bye.
Stay cool, everybody.
Yes, in my basement or my tardigrade.